Question 2d. A salad, which is initially at a temperature of 25 degrees Celsius, is placed in a refrigerator that has a constant temperature of 3 degrees Celsius. The cooling rate of the salad is proportional to the difference between the temperature of the refrigerator and the temperature, capital T, of the salad. That is, capital T satisfies the equation d capital T dt is equal to negative k times capital T minus 3, where T is the number of minutes after the salad is placed in the refrigerator. Part 1. Show that capital T equals 3 plus ae to the power of negative kt satisfies this equation. I'm going to answer this question by solving the differential equation by separation of variables. So firstly, to separate the variables, we have d capital T over capital T minus 3 is equal to negative k dt. Next, we integrate both sides of this equation. So what we do on one side, we've got to do to the other. Now the integral of d capital T over capital T minus 3 is ln of capital T minus 3, and the integral of negative k dt is equal to negative kt plus the constant of integration c. Next, we raise both sides of this equation to base e. So we have capital T minus 3 is equal to e to the power of negative kt plus c. Adding 3 to both sides of this equation and splitting this term up by expressing it as a product of two terms of base c by applying one of the index laws, we have capital T is equal to 3 plus e to the power of negative kt times e to the power of c. Now since c is a constant, e to the power of c is a constant. I'm going to let a equal e to the power of c. So replacing e to the power of c with a, we're going to have capital T is equal to 3 plus ae to the negative kt, and this is a solution to the differential equation. Part 2. The temperature of the salad is 11 degrees Celsius after 10 minutes. Find the temperature of the salad after 15 minutes. The following are the marking guidelines for question 2d, part 2. For 1 mark, we have evaluates A or equivalent merit. For 2 marks, we have evaluates K or equivalent merit. And for 3 marks, we have correct solution. The first step is to find the value of A by applying the initial condition, capital T equals 25 when T equals 0. That is, the salad is initially at 25 degrees Celsius at time T equals 0. So substituting capital T equals 25 and T equals 0 into the equation, we have 25 is equal to 3 plus ae to the power of negative k times 0. And e to the power of negative k times 0 is equal to 1. So we have 25 is equal to 3 plus a, therefore a is equal to 22. The next step is to find the value of k by applying the boundary condition, that is, the temperature capital T is equal to 11 degrees Celsius at time T equals 10. So substituting capital T equals 11 and T equals 10 into the equation, we have 11 is equal to 3 plus 22 times e to the power of negative 10k. Subtracting 3 from both sides of the equation, we have 8 is equal to 22 times e to the power of negative 10k. Dividing both sides of the equation by 22, we have 8 over 22 is equal to e to the power of negative 10k. Taking the natural logarithm of both sides, we have ln of 8 over 22 is equal to negative 10k. And finally, dividing both sides by negative 10 to make k the subject, we have k is equal to negative 1 over 10 times ln of 8 over 22. And I'm going to leave k in exact form. Now when time T equals 15, the temperature capital T is equal to 3 plus 22 times e to the power of negative 15k, and we have the value of k, which I'm going to substitute into this equation. And we have capital T is equal to 7.824. Let's correct the 3 decimal places. So therefore, after 15 minutes, the salad is 7.824 degrees Celsius, correct to 3 decimal places. The following is the feedback from the Marking Centre for question 2d. For part 1, this part was done well. with many candidates correctly stating that d capital T dt equals negative k times a times e to the power of negative kt, and then substituting into the differential equation to prove the result. There were several who chose to do the proof by integrating. For part 2, this question was very well done by many candidates. A common error was to use A equals 25, which was the initial temperature.